Welcome to this video on steam locomotives in Harz, tracing their journey from mining pumps to tourism. We will cover the history, technology, and heritage of these magnificent machines. This video explores the transformation of steam technology in the Harz region. We will look at how the power of steam moved from draining mines to powering mountain railways for tourists. A contemporary definition of a steam locomotive. It's a traction vehicle where the energy source is steam from water, typically produced by burning coal in a boiler. This energy converts into mechanical motion to drive the wheels. The steam era began with the mining pump. Flooded mines in the 17th and 18th centuries needed solutions. Thomas Newcomen's 1712 steam engine provided a practical way to pump water, with steam driving a piston. James Watt, a key figure in steam engine development, introduced important improvements. His most famous addition was the centrifugal governor, an automatic mechanical device that regulated the machine's speed. George Stephenson, a pioneer of the steam railway, created the rocket in 1829 for the Rainhill trials. The goal was to find the best steam locomotive for regular operation on the Liverpool-Manchester Railway. The rocket introduced several key technical innovations. These included the multi-tube boiler, a steam ejector in the chimney for better combustion, and direct drive to the wheels, all of which became standards in later steam locomotives. The rocket achieved a maximum speed of about 45 to 50 kilometers per hour. Weighing around 4.3 tons and fueled by coal, these performances were considered revolutionary in the 1820s. Historically, the rocket was significant as the winner of the Rainhill trials and a design blueprint for future steam railways. It proved that steam rail transport was safe, efficient, and profitable, launching the modern railway era. Mineral coal formed over millions of years from plant remains through processes of pressure and heat. The carbon content increases with depth and age. Coal became a vital fuel for steam engines and industry. The evolution of coal extraction technology moved from initial manual methods in open pit and underground mines. Later innovations included mechanical hammers, steam pumps for drainage, and mine wagons for transport, leading to increased raw material availability and lower costs. Coal processing involves classifying the raw material by quality and calorific value, followed by drying and sometimes pre-sintering to produce coke. High-quality, high-calorific coal was essential for powerful steam locomotives and heavy industry. Comparing calorific values, lignite offers about 12 to 20 megajoules per kilogram, anthracite about 24 to 30, and crude oil 42 to 46. Despite its lower calorific value, coal was cheaper and more readily available than oil in the 19th century. The main coal extraction centers in the 19th century included Great Britain, Germany, the USA, and France and Belgium. These regions fueled the development of steam railways and factory industry. Coal was the ideal fuel for locomotives due to its high calorific capacity, which created powerful steam. Its ease of transport and storage in stations and wagons, along with its availability across Europe and America, was crucial for the steam era. Steam locomotives enabled rapid coal transport from mines to cities and factories. This led to the establishment of the first dedicated coal railway lines. Local mining railways efficiently connected mines with forges and ports, increasing the pace of industry and the availability of coal. Steam engines provided a stable energy source for factories. Steam trains accelerated commerce and urbanization, linking coal and steam to power modern industry. Historical examples include Great Britain, the German Ruhr and Rhineland, and Harz, where local locomotives transported coal to forges and factories. Steam locomotives were catalysts for 19th century economic change. The Harz region presents challenging, rugged terrain with steep slopes and narrow valleys. Tight curves and limited space posed a significant challenge for railway construction. The main challenge was constructing tracks and adapting steam locomotives to the mountainous relief, requiring special technical solutions. Technical adaptations included narrow-gauge locomotives, Harzer Schmalzbahnen, with reinforced boilers and brakes. They also used special wheels or ABT rack systems for better traction on steep slopes. These adaptations ensured safety and stability during the transport of both goods and passengers, allowing steam locomotives to function efficiently in mountain conditions. The Harz narrow-gauge railways are an extensive network of narrow-gauge mountain railways, stretching over 140 kilometers in the Harz region. Steam locomotives have been used on this network since the 19th century and continue to operate today. They serve both freight transport and tourism. The Harzer Schmalsperbahnen stands as a living museum of steam rail transport. The Harz narrow-gauge railways are a testament to the ingenuity required to build railways in challenging mountain terrain.